A key thing is to notice how symmetrical the normal curve is. So the mean, the average car price is $20,000, and an equal number of people are paying more than that, and an equal number of people are paying less than that, and 20,000 is right in the middle. And the 68, 95, 99.7 rule tells us a little more information when we include the standard deviation. So just to quickly go over that, if the standard deviation is 1,000, that means if you start from the mean and go 1,000 above and 1,000 below, that 68% of people will pay within that range. If you go 2 standard deviations, so in this case 2,000 above and 2,000 below, 95% of people will be within that range. And then 3 steps above to 3 steps below, 99.7% of people are within that range. So this problem says, what's the percentage of buyers who pay between 20 and 22,000? So 20 to 22,000 would be right here on the graph. And now you have to use the 68, 95, 99.7 rule and the fact that the graph is symmetrical. So 95% of people pay between 18 and 22,000. But we're only looking at half of that region, only 20 to 22,000. We're cutting off, ignoring the other half, the 18 to 20. So we're looking at half of the 95% of people, and half of that is 47.5. So you can think 47.5% of people pay between 18 and 20, and another 47.5% of people pay between 20 and 22. Altogether, that equals 95. This problem is similar. Now the mean is 24, and their standard deviation is 2,000. So 68% of people pay between 2,000 above and 2,000 below. So this question says, find the percentage of buyers who paid more than 30. Again, use these percentages with the fact that it's symmetrical. So in between 18 and 30, we know that's 99.7% of people. Almost everybody. So the people who pay more than 30 and the people who pay less than 18 are the only ones left off of this percentage. And so that would be 0.3% who pay more than 30 or less than 18. Well, half of them pay more than 30 and half of them pay less than 18 because of the symmetry of the graph. So half of that 0.3%, that 0.30% is 0.15. So there's 0.15 above 30, there's also 0.15 below 18. So the percentage who pay more than 30 is 0.15. So for 25 here, what percentage of buyers paid less than 17,000? Well, let's use the 68% are in between 17 and 19. That means the other 32% are split equally, with 16% below that and 16% above that. So the people who paid less than 17,000, there'd be 16% there. Just like there's 16% who paid more than 19,000. Altogether that equals 32%, because the other 68% are in between 17 and 19. And I also wanted to look quickly at 26 and 27. Let me pull up a notepad here. The mean is 50 and a standard deviation of 7. And the problem says convert 50 to a z-score. The way you do a z-score is you're going to take whatever the number is In this case, they told us the number was 50. So you take the number and you subtract the mean. Sorry, my writing is a little ugly. In this case, the mean is actually 50 as well. So the number minus the mean and divide by the standard deviation, which was 7. So you divide by the standard deviation. Well, in this case, we get 0 divided by 7, which equals 0. We're basically trying to see how far away is that number they tell us. In this case, the number was 50. How far away is that from the mean? And this is our measuring stick, the standard deviation. And so 50 is 0 away from the mean because the mean was 50. If instead of convert 50 to a z-score, if it said convert 57 to a z-score, well, how far away is 57 from our mean? If this is our measuring stick, it's exactly 1 measuring stick away. It's exactly 7 away. And you can see that from our formula. If instead of 50 I was using 57, then I take the number, I subtract the mean, I would now get 7 divided by 7. Which equals 1. So 57 is exactly 1 standard deviation above the mean. Let's look at 27 with some different numbers. It's about dental exams. It says the mean is 11 and the standard deviation is 4. So sorry, this is a little slow here. That'll be a little faster. Alright. So here's the number they give us, 7. And we want to know how far away is 7 from the mean. So we take the number 7 and we subtract the mean, which they said was 11. And the standard deviation is 4. So here we get negative 4 divided by 4. So if someone said their dental anxiety was a 7, they're exactly 1 standard deviation below the mean. That's why it's negative. And this is the formula you can always use to find the z-score.